I'm Kumar. Welcome to my series on providing you with solutions of some international test paper. Here I have picked up a question from June 2018 Advanced Mathematics GCSE test paper. Now this question is based on vectors. Question number 2 is relative to a fixed origin O, the point A has position vector 2i plus 3j minus 4k, point B has position vector 4i minus 2j plus 3k, and point C has position vector ai plus 5j minus 2k, where a is a constant and a is less than 0. D is a point where AB is equal to vector BD. Part A is find the position vector of D, that is part A, and then given that the magnitude of AC is 4, find the value of A. You can always pause the video, answer the question, and then look into my suggestions. Now normally you're supposed to answer in black ink in this space provided. However, I'll give you solution, rather hint of the solution right there in the space. So we'll be having a close look at the question as we solve. So let's work with part A, where we are given that the vectors AB and BD are same, and we need to find the position vector D. So let us say that the position vector D is xi plus yj plus zk, right? Where I, j, k are unit vectors along the direction x, y, z. So when we say that AB, let me just push this. Okay, when we say that the vector AB is equal to vector BD, then AB means what? So AB is B minus A, right? So OB minus OA, right? So that is what it is. So which we could write here as 4 minus 2, right? This is B and this is A, so 4 minus 2. Minus 2 minus 3, 3 minus, that becomes plus 4, right? Equals to B to D. So X, Y, Z are D components, right? X, Y, and Z. From here, we'll take away the B components, which are 4 minus 2, 3, right? So 4 minus 2 makes this, and then 3. Clear? So that is what it means. So from here, we actually get 3 different equations. And we could actually equate each to find the value of x, y, and z. So we have x minus 4 equals to 4 minus 2 is 2. So that gives you the value of x as equal to 6, right? Now the other one is y plus 2 equals to minus 5, and that gives you the value of y as minus 5 minus 2, which is 7. And then we have z minus 3 equals to 7. So that means 7 plus 3 is 10 for z. Right? So that gives you the value of D. So vector D basically is 6i plus 7j plus 10k. Clear? So that is how we are going to find this particular solution. Now, oh, sorry, this is minus 5, this is minus 7, sorry. Minus 2 minus 3 is minus 5, and when you take away 2, it becomes minus 7, right. So that is how you get part A. Now, let's look into part B. We are given magnitude of A to C is 4. We need to find the value of A. So let's find the vector AC first. Vector AC means we have to look into these two, correct? C minus A, right? So that is, we have A minus 2, then we have 5 minus 3, and here we have minus 2 minus minus 4, right? Which is plus 4. So that becomes AC. So what is the magnitude of AC? Well, let's write the magnitude square, right? So magnitude square will be A minus 2 whole square plus 5 minus 3 whole square plus minus 2 plus 4 whole square. And this is given to us as 4. So we could write this as 4 square equals to all this, right? Which is a minus 2 whole square plus 5 minus 3 is 2. 2 square is 4. And here we have 4 minus 2 as 2. 2 square is again 4, right? So we have 16, take away 8 equals to a minus 2 whole square. 16 take away 8 is 8, right? Square root of 8, which will be plus and minus, equals to a minus 2. And that gives you the value of a as equal to 2 plus minus square root of 8, right? Now, since we know that a is less than 0, we'll take the negative value, right? So for us, a actually is equal to 2 minus square root of 8, right? So we can write the value of a as equal to square root of 8 can be written as 2 square root 2, right? So 2 minus 2 square root 2. So that becomes the exact value of a, right? So that is how you would actually answer this question. So I hope it makes sense, right? So we'll take this negative value only since a is a constant and a is less than 0. So I hope that makes sense. Feel free to write your comment, share your views, and if you like and subscribe to my videos, that would be great. Now if you have any questions, you can always email on the address given here. Thanks for your time and all the best.